Hello and welcome, I'm your Code Monkey. In this lecture we're going to add a nice visual to our plate. Okay, so right now we can already pick up ingredients onto the plate, so if I pick up the plate and I pick up some cheese, there you go, there's some cheese on the plate, but we cannot see it, so let's solve that. And the way we're going to do that is actually in a very simple way. If you look in the included assets inside the prefab visuals, there's this nice plate complete visual that I built. Basically, it's a full burger that contains all of the ingredients. What we're going to do is actually very simple. We're just going to enable or disable these game objects. That's it. So let's do exactly that. Let's make a new C# script. Call it the plate complete visual. Let's attach the script over here. And let's also make sure to put this one inside the plate. So let's save this prefab. Let's go inside the plate prefab. So inside the prefabs, here the kitchen objects, we've got the plate. So inside the plate, let's drag that. Let's drag the plate complete visual. Okay, great. So now let's open up this script. Over here, let's first add a reference to our plate kitchen object. So a serialized field, private for the plate kitchen object for the plate kitchen object. Back in the editor, let's drag the reference. Okay, great. So now here, basically, we need to update this visual whenever the plate gets any ingredient added to it. So let's go over here into the plate script and basically just need to fire off an event when that happens. So let's make a public event handler. And let's call it on ingredient added. Okay, and for this one, let's also make an event args to contain the data of what object we added. So let's make a public class on ingredient added event args. Let's extend event args. And inside, let's make just a kitchen object SO, kitchen object SO. Okay, great. And let's make the event of this type. Alright, so now let's just fire off this event. So down here, when we try to add an ingredient, if we do add the ingredient, let's fire off this event. So let's invoke with this, and let's create a brand new one, passing the kitchen object SO as this kitchen object SO. Okay, so we have our event correctly being sent. Now over here on the plate complete visual, let's listen to it. Again, as always, let's make sure to do it only on start. So the plate kitchen object on ingredient added, let's listen to this event. And over here, we just need to either enable or disable the visuals that relate to the kitchen object inside over here, the event args. However, of course, the question is, how exactly do we find them? The plate complete visual has all of these game objects. How do we know which one belongs to that kitchen object? Now, technically, one way would be to do a simple transform find and find the child objects by name. Technically, that would work, but like I mentioned in the beginning of the course, strings are a horrible way to identify things. They are very error prone. So let's not do that. Instead, let's use a proper approach where we can define some kind of link between a kitchen object SO and a game object. And we can do that very easily by just defining a struct. So up here in our script, let's do exactly that. Let's define a public, make it a struct, and name it kitchen object SO underscore game object. And then inside, it's very simple. We just have a kitchen object SO field, and then also a game object field. That's it, super simple. By the way, if you don't know what is a struct, basically it's very similar to a class, except it's stored in different places in memory and behaves somewhat differently. I have a very important video on that subject, what is the difference between value types and reference types. Classes are reference types, so when you pass in a class into a parameter, you are passing in a reference to that object. Whereas structs are value types, so when you pass in a struct onto a parameter, you are passing in a copy. It's a bit of a tricky thing, so definitely make sure you go watch that video for more detail so you don't get confused in the future. Here I defined it as a struct simply as kind of a teaching moment, but also because it just makes sense that if I just want to store some data without any logic, then it should probably be a struct and not a class. Although in this case a class would work just as well. Anyway, so here we have a struct. Inside the struct, we have a field of type kitchen object SO and another one of type game object. So now let's just make a list of this type that we can expose in the editor. So up here, a serialized field, private, let's make it a list of kitchen object SO game object and call it kitchen object SO game object list. Okay, that's it, super simple. So let's save and make sure this compiles. So actually, let's just comment this out, just make sure our code compiles, okay? And over here in the editor, we see the tricky thing when it comes to using fields of custom types. If we look in the inspector, nope, we don't see anything, so we cannot see our custom type in the inspector. If you make a custom type like this struct, and you want to show it in the inspector, then you need to add the attribute serializable, which exists inside system. So let's go up here using system. And let's add the attribute serializable, just like this. Okay, so do this, save, and let's look. And yep, there we go. Now we do see our custom struct. So we've got a list, and we can click on the plus icon, and there you go, we've got an element, and it does have a field for a kitchen object SO and one for a game object. So that's great. With this now we have a really nice place where we can link one object to another. So let's just do exactly that. So for example, let's put the bread over there, and let's assign the kitchen object SO for the one with bread. Let's do the same thing for all of the others. So let's add a whole bunch more. Okay, so we've got the bread, then we're going to have the meat patty cooked, then the tomato slices, then we have the cheese slices, the cabbage sliced, and finally the meat patty burned. So we've got numbers 0 through 5, so we have 6 elements, and over here, yep, we do got 6, so we have all of them. We can get rid of these last 2, okay, great. And now let's assign the proper objects, so this one for the meat patty cooked, then we've got the tomato slices, then we have the cheese slices, then the cabbage slices, and finally the meat patty burned. Okay, great, so all of the references match. Now back in the code here, so we have this list fully filled out. And when we have this, it's really very simple. We just cycle through the list to find the right game object. So let's do a for each of type kitchen object SO game object in our kitchen object SO game object list. And we check if this kitchen object SO dot kitchen object matches the one that we received in the event. If they do match, then go into this one, grab the game object, and set active into true. Okay, so that's it, some very simple logic. And also we can start with them disabled by default in the editor, or just over here, just do something very simple. Just do a for each, cycle through every single one of them, and set every single one of them to false, so that they are hidden. Okay, so with this, all the ingredients on the plate should be visible. So here in the editor, let's just make sure all the references have been set. Let's go back, save the prefab, and let's set on play. Okay, so here we are, and by default, look at that, an empty plate, and yep, it is empty. And now let's slice some cheese. Now let's place some cheese on there, and yep, there you go, we've got some cheese. Now let's pick up some bread, drop some bread, and there you go, got some cheese and some bread. Then let's cook some meat. So let's cook it, and let's pick it up with a plate. And as soon as I go, boom, there you go, I've got a nice cheeseburger. All right, awesome. So with this, I can now do a complete burger, so let's finish it. Let's just add some more tomatoes, so slice them and add the tomatoes. And finally some sliced cabbages, slice them, put them there, and there you go, here we have a fully complete burger. Okay, so that's great, all of our visual logic is indeed working. However, this visual is a bit hard to see, it's not very clear to the player. So just looking at it from this distance, does that have a tomato or not? There's a tiny sliver of red in there, but you can't really see it. So we should probably add some nice clear icons on top to clearly indicate what exactly is on this plate. So that's exactly what we're going to do in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some really nice icons on top of our plate so we can easily see what is on there. Okay, so for the icons, let's do the exact same thing that we did for the progress bar, meaning let's use a world space canvas. So let's go inside our plate kitchen object prefab. And over here, let's right click, let's create a brand new canvas. Let's name this the plate icons UI. Then for the settings, let's make it world space, put it on 0, 0, everything, width and height also on 0. Then let's lift it up a little bit, so put it on a Y of 1, okay, like that. Now inside, let's define an icon. So let's start by making an empty game object. Call this just the icon template. Let's put it with a size of 0.3.3, so okay, something like that. Then inside, let's add a new UI image, name this the background, and make it stretch to fill the parent, so put 0 on everything. Okay, there's our background. For the background image, instead of a square, let's actually go with a circle. For that, Unity actually has a bunch of built-in sprites that it added in the last versions. However, it's not actually over here by default. In order to see those default sprites, we need to install the 2D sprite package. So let's quickly just go into Window, Package Manager. Let's make sure we are in the Unity registry, make sure we are looking at all. And over here, let's find the 2D sprite package. Okay, so let's install this. Okay, there's the package. So now if we go into the background and we search for a sprite, and over here, make sure you click to actually show the assets from the packages. And now we see a bunch of default hexagons, a bunch of isometric tiles, a square, so on. And if we search for a circle, yep, here we've got a bunch of circles. So let's use this one over here on this path, so let's use it. There you go, we have a nice circle. Now let's duplicate this image, and for the second one, let's name it icon. And for this one, let's assign just a random sprite, so let's say the bread. And again, remember how the sorting order on the UI, this one is based on the order in the hierarchy. So make sure that the icon is underneath the background in the hierarchy. That way it shows up on top. Okay, so we have our icon template. That's great. Of course, we're going to dynamically generate all of this through code. We're going to have multiple icons, and for positioning them, Unity actually has some really useful components. Let's select the plate icons UI, and over here let's add a component. Now, for example, a built-in component is the grid layout group. This basically helps you position all of the child objects. So let's put the size of the canvas over here on 0.9.9. Okay, so there you go, a nice square window. Then over here on the settings for this, for the cell size, let's put it at 0.3.3. And if there you go, already shows up over there on the corner. And we can see what it will look like if we just duplicate this object. So let's make a bunch more templates. And if there you go, that's what it looks like. So as you can see, this component is super useful for automatically positioning all of the child objects. Now, if we want, we can play around all of these. We can add a little bit of spacing on the X or on the Y. But let's actually leave both those with 0. Let's leave everything on defaults. Just over here on the child alignment, let's put it on middle center. Okay, so there you go. That looks pretty nice. So you can see how this built-in component is super useful. There's actually two more. So this one for the grid layout group, this is great when you want to put things horizontally and vertically. But if you just want horizontally, then there is the horizontal layout group. And if you just want vertically, there's the vertical layout group. So all of these components are really awesome, really useful. Okay, so with this, our objects are placed. And note how I named this an icon template. Basically, a template is just what I call something that is kind of like a prefab, but not really a prefab. Through code, we're going to duplicate this template and dynamically modify the icon. So we're going to use it very much like a prefab. We could actually make this into a proper prefab, so I could just drag it over here onto the project files and make a regular prefab. That could work, and the only reason why I prefer this method of not using a prefab is just because this object, this template, stays here on the object as opposed to cluttering over here your project files. If you have tons of single-use UI elements with tons of objects you need to spawn, you can end up with tons and tons of prefabs, and you might not even know where each of those is used. Whereas with this method, the template stays exactly where it's used and does not take an asset slot over here on the project files. So personally, this is just the approach that I prefer for spawning UI elements. But like I said, prefabs work as well, so if you prefer using prefabs, go ahead and make it. Okay, so let's make our script to run the plate icons UI. So let's go into our scripts, and on the scripts folder, let's create a brand new C# script for the plate icons UI. Over here, let's attach a script and open it. Okay, so now the first thing we need is a reference to our plate. So let's begin by making a serialized field private for the plate kitchen object for our plate kitchen object. Okay, let's save it and drag the reference. So over here, there's the plate icons. Let's just drag the plate reference. Okay, great. Now on the plate, we already made this event when an ingredient is added. So basically, we just need to listen to this in order to add the new icon. So over here on the UI, let's do, as usual, private void start. And on start, let's go into the plate kitchen object and listen to that event. And when that happens, let's spawn an icon. Although here, let's actually use a different method from the one we used on the plate visual. Over here on the plate visual, whenever we had the event, we really just modified the object that was added. So over here, the equivalent would be to spawn a new icon whenever that one was added. But instead of doing that, right now, let's listen to this event, and when this happens, let's update all the icons in this display. Basically, this other method is useful when the contents can be added as well as removed. Now, in this case, they are never going to be removed, so in this case, both methods work fine, but still, I want to show you the second method just so you can use it when you need it. So for that method, we just need to know exactly what is on the plate. So over here on the plate kitchen object, we just need to expose the kitchen object SO list. So let's do exactly that. So public, we're going to return a list of kitchen object SO. Let's call it get kitchen object SO list. And we just return the kitchen object SO list. Okay, very simple. Then over here on the plate icons UI, let's just make a function to update the visuals. So private void, let's call it update visual. And when we have the event, let's call our update visual. Okay. So now here, let's basically just cycle through all the ingredients. So let's do a for each kitchen object SO in the plate and get the kitchen object SO list. Okay, so we're cycling through all of the ingredients on the plate. And then we want to duplicate our template. So that means we need a reference up here. So let's add a serialized field, private, type transform, call it the icon template. Okay, let's save the code. And over here in the editor, let's drag the reference, so let's drag the icon template. By the way, I left the others over here. That's not a problem since these are going to be destroyed, those we're going to see in a little bit. The only one that matters is the first one. Okay, so here we have the icon template. So to spawn it, we do it just like we do with any prefab. So we just call instantiate, pass in the icon template, and then transform parent, so let's put it as a child of this object. This part is important. We need to make sure the object is spawned as a child of this object. If over here you put something like null, then the template won't be spawned as a global object, so it won't be somewhere in the world. So in order to make it positioned properly, let's make sure to use transform to become a child of this object. Okay, and then since we're using the other script, the grid layout group, this is already going to be automatically positioned. So just like this, it should be spawning the icon. And with the icon spawned, all that's left is really just setting the image. And now again, the quick and dirty approach would be over here when we spawn. Let's say we pick up the item transform. And over here we could go inside and do a find in order to find the image, in order to get the component of type image and so on. So that is one approach. That would be the quick and dirty approach. But again, we want to do things properly, so let's do it the proper way instead. So instead of this, let's make a proper script that we're going to run on the icon template. So let's create a new script. So a new C# script, call it the plate icon single UI. So this one represents just a single icon. Let's go ahead and attach it to the template. So over here, let's drag it. And now when using this template method, really the only one we need to worry about is this one. The other duplicates, we can just leave them. They don't really matter. But still, just to avoid confusion, I'm actually going to delete them. So okay, we just have one icon template, okay, and it has our script. Okay, let's open. Now over here, let's basically just make a function to set a kitchen object SO. So public void, let's call set kitchen object SO. And we receive parameter of type kitchen object SO. Okay, great. So then we need to set the image. So let's just go into a serialized field, private of type image, which is inside unityengine.ui. So for this one, for the image, we have a reference, and then we set the image.sprite, go into the kitchen object and grab the sprite. Okay, so all we need to do is drag this reference. So over here in our template, let's drag the icon image. Okay, great. So now back here on the plate icons UI, so we spawn it, that's great. Then let's do a get component in order to get our script. So the plate icon single UI, okay. And then we just call set kitchen object SO and pass in this. Okay, that's great, this is much better. Now again, you might be thinking that this method is a lot more verbose than just setting the image sprite here. We had to create another completely new script. We had to write this logic and over here get it and use it. The quick and dirty approach would indeed be quicker, but remember that while the quick and dirty approach might be faster at first, it will mess you up over time. So just take a few extra seconds to do things properly. This approach is much more scalable. Let's say for example, on this function, you want to change not just the sprite, but also trigger some kind of spawn effect or animation. With this, it's very simple. We've got this function right here. We receive the kitchen object SO and we can do whatever we want with it. So like this, we have this script that is responsible for anything related to the single template. And we've got the general one, which just spawns them and just gives them the kitchen object SO. So all of our logic is nicely separated. Okay, so just like this, it should already work. However, like this, you might already be thinking, won't this spawn way too many icons? And yep, it will. Basically, every time we add an ingredient, we're updating the visual, where we're cycling through every single one and spawning all of them. So with this, we're constantly going to spawn more and more items. This is not what we want. Over here on the update visual, we do want to update and spawn all of the icons. But before we do that, we actually need to clean it up. We need to clean up the icons from the previous event. So before we do that, let's just cycle through all the children on this transform. So that's pretty simple. You can just do a for each transform child in the transform. So this way cycles through all the children. And then just call destroy on this child.gameObject. So that won't work. That won't destroy all of the previous children. However, of course, we also have one issue. The icon template itself is also a child. So if we do this, we're going to destroy the icon template, which then over here we're going to have an error because we're going to instantiate null. So we want to destroy all the children except for the template. So over here, that's pretty simple. We just check if the child equals the icon template. If so, then let's just skip it. So we can just call continue, and there you go, it skips. Okay, great. So just one more final thing. If we leave the template like this, meaning the game object is enabled, like this, the template will always be visible plus whatever ingredients we have. We don't really want the template to be visible. This is just meant to be a template that we can instantiate. So that's pretty simple to fix. Let's make a private void awake, and on awake, let's grab the icon template, grab the game object, set active into false. Okay, so now the icon template won't be disabled, so it won't be visible. And then over here, when we are instantiating, the instantiated ones will also be disabled. So let's make sure we go in there and enable these. All right, that should do it. So all of our logic should be working. There's only one more tiny thing we need to take care of. This one is a world canvas. So like we saw with the progress bar, we need extra logic to make it look towards the camera. And thankfully, we already wrote an excellent generic script to do just that. So let's go into the plate icons UI, and let's add a component, and let's add our very nice look at camera. So like this, and let's set the mode the same that we use, so let's put it camera.forward. Okay, so everything is great, everything should be perfect, so let's finally test. Let's leave the scene, save the prefab, and hit on play. Alright, so let's go pick up a plate, and there you go, there are no icons visible. Okay, that's great. Now I'm going to place a bread on top of the plate, and there you go, I've got a nice bread icon. Okay, great, now let's make some meat, cook it, and as soon as it's done, I'm going to pick it up, and there you go, I've got a bread and some meat. Now let's put some cheese, slice it, put it there, and there you go. Now I can easily see that plate has some bread, some meat, and some cheese. Now let's just add the rest of the ingredients to make a full mega burger. So let's add some tomatoes and add some nice cabbage slices. And yep, there you go, it works perfectly. So here we have a complete burger with everything, and we can easily see on the icons everything this contains. Alright, awesome! Okay, so here you'll learn how to make yet another super useful element that you can easily add to all of your games. Personally, I use this kind of logic a ton in all kinds of UI things. For example, in my upcoming Steam game, Total War Liberation, the items in the inventory, they're all added using this method. So there's a template and I duplicate that template. Same thing for all of the action buttons. All of those are based on having a template and duplicating it. It's a really easy way to do this kind of thing. With all of that, here we have a full plate and we can easily see what is on there. So with this, the next obvious step is to actually deliver some orders. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build the delivery counter. This is where we're going to drop some items that the customers have requested in order to complete the orders. Also, just for fun, we're going to learn how to use shader graph to make a simple custom shader. Okay, so let's begin by making our counter. So let's go into our base counter, let's create a new prefab variant for the delivery counter. Let's go inside and now let's find the visual for delivery counter. Let's duplicate it to make the selected. Let's go inside, modify the material. Then on the selected, make it 1% bigger, 101, add the component, the selected counter visual. Let's drag the kitchen counter like that. Okay, that's our basic setup. And also start with the kitchen counter disabled. Okay, great. Now let's make a script to run this. So let's go into our counters folder. Let's create a brand new C# script for the delivery counter. Let's attach it and open. Okay, so now here as usual, let's begin by extending our base counter class. All right. Now let's override the interact function. And for now, let's actually do it exactly like the trash counter, meaning let's just destroy the object. So we just check if the player is holding something. So if the player has a kitchen object, let's go into the player, the kitchen object, and let's destroy it. However, another rule over here for the delivery counter is this is only going to accept plates. So let's see if the player is carrying a plate object. So player get kitchen object and test try to get the plate. So out plate kitchen object for the plate kitchen object. We try to get this, and if it is a plate, then we destroy it. Okay, that's it. Here in the editor, let's just compile the script and drag the references. So the counter top point, and on the selected, let's drag the counter reference, and let's exit this, save the prefab. And let's drop it over here on the corner. So let's find over here the delivery counter. Let's put it over there. Angle it on this side. Put it like this. Let's also just quickly reposition all of our counters, since we already have all of the types that we're going to use. So on delivery counter, let's put it over here on this corner. So X 7.5, 0, and Z of 2. Then next to it, let's put the plates counter. So over there, okay. Then next to it, let's put a clear counter. After that, let's put the trash counter. And then let's also put another empty one there. So let's duplicate this one, move it up to about this and put it like that. Now we just need to move all of these down here. So just select all of these counters and let's move them down by about this. Okay, so on -5.5 like this. Okay, so everything is nicely positioned. just over there. Right now we cannot access that container, so let's actually modify those as well. Which, by the way, over here there's the canvas in front, so as I click, I'm actually selecting the canvas in the hierarchy. So here's a quick Unity tip. On the hierarchy, on the left side, you've got these two buttons. So one of them hides the object and the other one simply makes it unselectable. So if I click on this and I click through, any of the click goes through the canvas. So that makes it much easier to select over here all the items in our scene. So let's just select all of these. Okay, all of these. Now just push them all to the side and make another empty one and put it over here. Okay, that's a nice layout. Now let's just finish the rest. So over here, let's just duplicate our empty counters and place a bunch more. Let's put one more to the side. And now these ones over here, so let's put it over there and rotate it here. And duplicate another one, and another one, and another one, and just one more. And get rid of this one. Okay, great. So here we have pretty much our complete map. Let's also just move the camera a tiny bit, just make sure that it is nicely organized. So put it over there, just so everything is nice and centered. Okay, so there's our map. Now let's get back to working on our delivery counter. We already added this code, so let's just quickly test. So here we are, and if I pick up something like, for example, some cheese, go into the delivery counter and interact, and nope, nothing happens because that one only accepts plates. Now if I pick up a plate, go there, deliver, and yep, there you go, it does work. Okay, great. So this is the basic logic that we want. For defining the actual recipe logic, we're actually only going to do that in the next lecture, but for now, let's add one more nice thing. Let's add a simple custom visual over here using shader graph. This is a great way for you to learn the power of shader graph and just how easy it is to use. This is a visual tool for making shaders. It's really very easy. Personally, I don't know how to write shaders with code, but I can build some pretty nice things using shader graph. As usual, I have a dedicated video on it. I also have an entire playlist showcasing how to make all kinds of interesting effects, and even one special video covering some changes in recent shader graph versions. So over here, let's learn the basics how to use it. So first, here in our project window, let's create a brand new folder. Let's name it just shaders. And now inside, let's create one. So let's create, then go up here into shader graph. Then we're using URP, so let's go inside there. And here we've got a bunch of options. Now don't worry about picking the quote-unquote wrong option. All this does is just create a template. So for example, if you accidentally create an unlit shader, you can then easily swap it out for lit. So right now, let's go with the unlit shader. And for the name, let's name it moving visual. Okay, there's our shader graph file. Now let's just double click to open it. And up here we have the nice shader graph window. By the way, you can make this full screen. So you can either right click over there on the tab and maximize, or alternatively you can just click on this window and you can use the hotkey shift space. And yep, there you go, it does maximize. Okay, great. Now by default we have this down the center. This is called the master stack. These are the actual properties that we're going to need to use. Then on the left side we have the properties blackboard. On the right side, we've got the graph inspector. And finally, down here, we've got the main preview. All of these windows can be scaled. And also, if you don't see these windows, or if you accidentally hide them, they're all up here on these three buttons. So the blackboard, that's on the left, the graph inspector, and the main preview. Okay, so now here we've got a nice empty board, so we can add whatever nodes we want. So we can right-click and go into create node, and then we can write something, or just click anywhere and press on space, and there you go. Now we can cycle through and browse all of these menus to see all of the nodes that exist. There's tons and tons of them. Or alternatively, just go up here and use the search bar. So for example, let's find the sample texture to the node. So here it is, this one. Okay, we've got this node. What this one does is it takes a texture and grabs the color from it. So on the left side of the node are the inputs, and on the right side are the outputs. Within the parentheses, you can actually see the types. So for the input texture, this one is of type T2, so that means it's a texture 2D. Then on the output, you can see there's a 4, meaning it contains 4 floats, which in this case refers to the 4 colors. So that's red, green, blue, and alpha. So for an input, we want a texture, so let's set it over here as a property. Let's click on the plus icon, and we've got a whole bunch of types. For texture, we want a texture 2D, so let's go with that. And then for the name, now usually there are two standard names. There's one called main text or base map. Main text used to be the more common name, but when working with URP, for some reason they decided to name the main texture as base map. So over here, let's stick within the URP standard and just call this base map. Okay, there's our property, and if we click the selected, and on the right side we can see the graph inspector, and we can see all the properties for this actual property. So we see a name, reference, and a bunch more things. Now the really important one is over here, the reference. This is the actual name that you're going to use if you want to interact with this shader through code. The name on the property, this one is just a text string, so this can be whatever you want. You can even have spaces and so on. Whereas the reference name, this is the really important one. And by default, when you set up a name, it should already set the correct reference. Usually the standard is to name it just like the name, both without any spaces and with an underscore in the beginning. So just like this. Okay, then we can give it a default texture. So let's go ahead and select something. For example, over here, the bread texture. Remember, this is just the default. This will not be hard-coded directly into the shader. We can then modify this. Okay, so we have our nice base map property definition. Now we can just drag it over here on the board, and yep, there it is. And now we can just click on the circle icon in order to drag a connection, and let's connect it over here onto the sample texture to the input. And yep, right away we do see it does work, so we are correctly sampling the texture. However, if you look on the main preview, over here there's still nothing. That's because we don't have this node connect to anything. We need to connect it to the final master stack in order to render something. So again, on the output over here we can see a 4, so these are all of our colors. And actually, one very useful node is the preview, since so many things in shader graph can be hard to visualize. So we can move these nodes around, and let's add the preview node. And this does exactly that, so you can fit it an input, and you can see down here what that input contains. So for example, let's drag just the red channel, and if there you go, over there we can see the red channel for this texture. We can drag the green channel, the blue channel, or look at the alpha channel. Yep, there you go, it does work. So this preview node is super useful for being able to see what your shader is actually doing. Over here we have the colors, so let's get rid of the preview right now. And in order to make it work, we really just need to connect the RGBA and go up here into the base color. And right away it should work, but you might not be able to see anything over here on the main preview. I believe this is a rendering bug in the current tech version, so right now nothing is shown. So if you still don't see anything, it's actually pretty simple. Just go up here on the top left side and make sure to save the asset. Okay, save it, great. Then let's exit from our maximize view. And now let's close this tab. Let's click on play just to play the game. Now let's stop playing. And now if we open the shader again, yep, there you go. Now we do see the shader compiling over there, that color, that is the shader compilation. And after a little bit, it should work. Let's just maximize this. So yep, there you go. There we do see our texture. Okay, great. So again, this is just a simple rendering bug on the current tech version. If you're watching this video in the future, chances are you don't even have this bug, so there's no need to worry. Okay, so right now we do see it working. We can see our bread texture, and it's currently being applied on a sphere. For our use case, we're working with 2D textures, so this would be best to be seen on a quad. So we can right click over here on the preview in order to select the preview mesh. So let's go with a simple quad, and yep, there it is, we have our nice quad. Okay, great. So over here we have our basic shader. All it does is just shows a texture, that's it. Now let's actually use this. And first, let's always make sure to save the asset. On the top left side, on the moving visual, if you see an asterisk here, that means you have unsaved changes. So always make sure to save them. In my case, I don't, but still, never hurts to save. Now over here in scene view, let's go inside our delivery counter, so let's open it. And now for the display for our arrow, let's make it a flat quad. So let's right click in the hierarchy, let's create a new 3D object, and let's make it a quad. Let's call this the delivery arrow. Let's place this on top of the counter, so let's rotate it to face upwards. By the way, on the rotation, make sure the color is facing upwards. Most shaders by default, they only render one face and not the other one. So make sure you put the face with the color upwards and not the other one. Okay, so let's rotate this one upwards. So there we go, 90 over there. And let's just put it just exactly on top of the counter, so just enough so that it's visible. Okay, great. So now let's make a material for our arrow. So let's go inside the materials folder, and over here, let's create a brand new material. Let's call this the delivery arrow. Let's make sure to use this material on the quad, so let's just drag it over there on the mesh render. Okay, so it's using our custom material. And over here on this shader graph drop-down menu, over here we can select what shader we want to use. So in our case, let's go inside the folder shader graphs, and inside, yep, here we have our moving visual shader. So let's go ahead and use this. And yep, right away we do see that it does work. Here we have our texture being drawn exactly on top of our material. Okay, so far so good. Now again here, remember one very, very important thing that I said. The texture that you define the shader, over here the default for the property, this one is only the default. The important one is the one that we have on the material. I'm emphasizing this point because I've seen a bunch of people make this mistake. If you modify the default texture whilst inside the shader, like for example if I change here from bread, let's say into the cabbage slices, if I modify that, note how it does not modify any materials that were created. We are only changing defaults. So if you want to change the texture that is actually used, make sure you change the one on the material that you created and not the default. I changed the default but did not change this shader. However, if I now were to make another material, which by the way, here's a quick tip. you can right-click directly on the shader file and go into create and create new material, and it will automatically create the material using that shader. And actually here it didn't update default just because I didn't save the shader. So I modified this one for the capture slices, and now if I save the asset, and now if I right-click there and I create a brand new material, and yep, now that one does have the new default. But again, remember, what you set over here is just the default. What really matters is what is on the material. After the material has been created, modifying the default here does nothing. So always keep that in mind. In most cases, you want to be changing the property on the material itself, not the default on the shader. Okay, let's just clean up both of these. Alright, so let's continue. Now here we have our sprite working, okay, except we don't want to show some bread, so let's actually use the proper arrow sprite. So let's select this one. And yep, it does work, it is printing the sprite. However, one obvious thing is that the arrow is not transparent like it should be, so let's solve that. Back in our shader graph, in order to make this a transparent shader, we need to actually go into the graph settings. So in the graph inspector, go into graph settings, and over here you see a bunch of settings that relate to the graph itself and not any selected property. So let's go into graph settings. For example, like I mentioned a while ago, you can modify between lit and so on. So this is where you would change that. You can also up here add multiple targets. So you can create a shader in shader graph and make it work with the universal render pipeline or the high definition render pipeline or the built-in render pipeline. All of those are supported through shader graph. Now for our goal, in order to make this a transparent shader, let's just go over here onto surface type, and instead of opaque, let's change to transparent. And as soon as we do, look what happens there, and if there you go, it adds a brand new alpha channel. If we just save the asset right now, and nope, look at that, it still doesn't work, it's still not transparent. Basically we made this shader transparent, but now we need to feed in the transparent channel over here onto the alpha. This is the one thing that is different from a previous version of shader graph. Previously you could just feed the alpha channel over here onto the base color, and shader graph would automatically apply it. But in recent versions, you need to add it over here separately. So if you have any issues with transparency when following some older shader graph tutorials, always remember this change. I covered that along with some other changes in a very useful video. So if you're following along some older shader graph tutorials, make sure you watch that video to learn what you need to do to update them to the latest version. Okay, so here on the symbol and texture, we already have the alpha channel, so we just connect this onto the master alpha. And right there, we already see it working. Let's just go ahead, save our asset, and here in scene view, yep, there you go, now we do see our arrow. Now, one more small thing, you might notice that from some angles it's not exactly transparent. Basically, it actually is transparent, but since we made this a lit shader, sometimes the light might make the transparent parts visible. One option to solve that is over here on the graph settings. Instead of making it lit, let's make it unlit. That would work. So yep, with the unlit shader, the transparency is perfect. But if you really want to keep it lit, then the other thing you can do is just over here play around with these settings. You've got smoothness, AO, and so on, and over here you can even modify the workflow mode. So for transparency, instead of making it metallic, let's go with a specular workflow. And then over here, set the smoothness to 1 and the ambient occlusion down to 0. And now if we save this shader, and look at that, and yep, now the transparent parts are indeed fully transparent. Finally, over here on the right side on the mesh render, if you want, you might want to play around over here with the cast shadows. So maybe you don't want this one to cast shadows. Maybe you don't want it to impact light probes and so on. Okay, so with this we have our nice transparent arrow. Let's make sure to save our delivery counter, so let's go outside back into scenes. And let's hit on play. And yep, there you go, we have our transparent counter with our nice arrow. Now we want the arrow to actually move. And doing that is actually super simple. Going back here in our shader graph, let's just modify default just so we can see the arrow that we want to see. So let's select the arrow sprite. Okay, there's our arrow. Now for moving, over here on the simple texture, we've got an input for the UV. The UV is what defines what portion of the texture we're going to grab, which by default just gets the whole texture. So since this field represents where we're going to grab from texture, by playing around with this we can grab different parts. So to do that, let's just add a standard UV node. So here it is, this is the standard UV channel. So if we connect this, then nothing changes, everything still renders exactly the same. But now we can modify this. And to do that, we're really just going to use some basic math. Remember that when working with shaders, even though you do see colors, everything is really just numbers. So a UV2 is just a number, the color is just a number, the alpha is just a number. So visually, everything might look like images, might look like colors, but really in the end, it's all just numbers. So for example, how do we move this texture? Well, it's actually pretty simple. We just add a number onto it. So over here on the UV, let's just add an add node. So this just adds two numbers together, very basic. So let's take the regular UV and let's add something on top of it. For example, we can make a vector 2 and let's put it on say 0.10, and let's add this one onto this one. And now if we drag this one onto the input, look over there on the preview what happens. And if there you go, look at that, it moves slightly to the left. So if I modify this one, put it on 0, there you go, at that, 0.1 on that, 0.2 on that, and so on. So you can see that by modifying here, I'm essentially offsetting the texture. I'm offsetting on the X, and over here I can also offset it on the Y. Basically, I'm offsetting the texture by 10%. The UV is a normalized value. This is not pixels. So that is why 0.1 is 10% regardless of how big the texture is. And if we go way past 1, then the texture essentially loops back. So this is really all we need. For our moving arrow, we're going to have 0 on the Y, and on the X, we're going to constantly either increase or decrease. That's how we're going to have our moving arrow. So again, the only issue here is that I'm modifying this manually. We don't want a fixed amount on the shader, instead we want a nice animation. So for that, we have the very useful, the time node. This one has various time-based outputs. The one that we want for this case is the time, which is just the total time. This one is constantly increasing since the start of the game by the number of seconds. So if you use this over here directly on the add, and there you go, look, that texture is constantly scrolling. Okay, so that's great, except obviously we have one issue. We don't want it to scroll diagonally. We only want to scroll in one direction. So for that, we can essentially create a simple property to act as our speed. So let's over here on the blackboard, let's create a new vector2, call it our speed property. And for default, let's default on say 0.1 on the X, 0 on the Y. And now if I drag the speed over here onto our blackboard, okay, great. This is basically a multiplier, so we just need to multiply the time by this. So let's add a multiply node. Also, by the way, quick tip, over here on each node, you've got a nice little arrow, so if you want to make it a bit more compact, so if you don't actually need to see the preview, so make that. And in this case, let's take our time, multiply by our speed, and then for the output, pass it into the add. Okay, so look at that, now it is indeed moving in this direction. And over here on the speed, we can play around the values. So if we put it at 0.5, now it's moving faster. And if I put it on the Y, now it's moving diagonally, put it 0 on the X, and now it's only moving vertically. Okay, so this is really what we want. Let's just go ahead, save our shader, and now let's just select our delivery arrow material. And over here, yep, we've got the speed. If you don't see it, make sure that on the speed property over here you have it exposed. So we have the speed, instead of moving on the Y, let's move on the X. And actually like this, it's reverse going backwards. So over here we can just put a negative value. So let's put it on -1. And if there you go, now the arrow is moving perfectly. Also here, let me make one important note. Just in case you're using this shader with a custom texture instead of the one included in the course, if you do that, make sure that the texture that you use, so over here I'm using the arrow texture. Over here on the arrow import settings, down here under wrap mode, make sure it is set to repeat. If you set it as clamp, you might get some weird visuals or nothing at all. In order for the texture to constantly loop and constantly repeat itself, that one needs to be set to repeat. Okay, so here it is in game and we have a really nice moving texture. For that, we created a simple but really nice, useful custom shader. Definitely go ahead and watch the various effects that I made in the shader graph playlist. This tool is super useful, definitely make sure you know how to use it. I've used it for making a building effect, I've made some nice outlines, a really nice wind shader, also a really interesting dissolve effect, and even a cool transition shader just like in the game Hades. So this really is a super powerful tool, make sure you watch that playlist to really learn how to use it. Alright, so here we learned about shader graph and created a really nice custom shader. However, the delivery counter still only has a visual, so let's create some proper logic for generating and delivering the correct recipes in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build a proper delivery manager that will generate recipes that the customers are ordering and validate to see if the player made the right dishes. Alright, so right now we have the player capable of making dishes. So for example, I can put some cheese, cook some meat, cut the cheese, and then pick up both of them. Then let's say pick up some bread, and there you go, got a nice cheeseburger, and deliver it. Okay, so that works, but right now they just vanish on the delivery counter. So there's no recipe we need to follow, no validation, none of that. So let's add both those things. Okay, first of all, let's make our script. So let's create a brand new C# script for the delivery manager. Let's make a new game object to run it. So a new delivery manager, attach the script. Let's make sure to keep things clean, so reset the transform. And also, by the way, since we're here, let's go ahead and put the plates and delivery counter inside the counter so everything is nice and organized. Okay, great. So let's open up this script. Now here, basically we need to define some sort of list to store all of the recipes that the customers are waiting for, which of course begs the question, what type is that going to be? Now, technically, one thing we could do, since a recipe is really just a list of kitchen objects, over here we could have a list of kitchen object. This would be our recipe list. Technically that would work, but that really looks quite dirty. Instead of having a list of a list, we should probably have a proper type for this. So let's write some good clean code and define a proper recipe scriptable object. Back in Unity, let's go inside the scriptable objects folder and create a brand new one. Let's call this the recipe SO. And over here, let's make this a scriptable object. So extend scriptable object, make the create asset menu. And over here for the fields, for the data that we need. Really, like I said, a recipe is just a list of ingredients. So just a list of kitchen object SO for the kitchen object SO list. Okay, that's it. That's really all the data that we need to define a recipe. Just to be able to identify them for the player, let's also add a public string for the recipe name. So just a nice name string. Okay, great. Now back in the editor, let's define. So let's go inside the scriptable objects and make a brand new one for our recipe SO. And now inside, let's create a brand new recipe SO. For this one, let's call it just burger. And over here, first of all, for the name, just name it burger. And then for the kitchen object list, well, to make a burger, first let's add some meat. And we want some cooked meat. We don't want to serve uncooked or burnt meat, so only the cooked meat. Then for a simple burger, obviously we need some bread, and that's about it. So some bread, some meat, that's our very basic burger. Now let's also make another one, so let's duplicate this one and name this one the cheeseburger. Over here, let's name it cheeseburger. And like name implies, has bread, meat, and obviously some nice cheese slices. So there you go. Okay, we have a cheeseburger. Now let's also make a mega burger, so something with everything. So let's call this one the mega burger. And over here for the string name for the mega burger. And for that we have meat, bread, cheese. Let's also have some nice cabbage slices and also some tomato slices. Alright, that's our mega burger with everything. And finally, let's also make just a nice simple salad. So let's duplicate this for a salad. Let's name it salad. And for the salad, we don't have any meat, we don't have any bread, and also no cheese. So just cabbage slice and tomato slice. That's a simple salad. Okay, so here we have all of our recipes. So back here on the delivery manager script, instead of making a list of game object, let's just make a list of recipe. Recipe SO, and name it the recipe SO list. This is where we're going to place the recipes that the customers are waiting for. So let's actually rename this. Let's put it waiting recipe list, okay? So the customers are waiting for whatever is inside this list. And now we could make this a serialized field and set it in the editor, but we don't want to have a fixed list. We want to periodically spawn new recipes. And in order to spawn new recipes, we also need to know which ones we can spawn. So for that, we could add a list of all of the recipes. Then we could pick a random one from the list and add it over here to the waiting list. That would work, that's one good approach. But since we already did something similar to that various times in this course, here let me teach you a different approach that sometimes might make more sense. For that second approach, we just need one thing. We need a scriptable object to hold all of our recipes. So let's do that. Let's do a brand new C# script. This is the recipe list scriptable object. And then inside, this one is going to be a scriptable object. Let's add the create asset menu. And inside, we're just going to have a list of recipe SO. For the recipe SO list. So that's it, super simple. Now let's just create one object of this type. We can put it inside the recipe SO list since we're only going to have one. So let's make a recipe list SO, name it the recipe list SO. And then over here, let's just drag our recipes. So we've got a burger, a cheeseburger, we have a mega burger, and finally a salad. Okay, so basically we have a scriptable object with all of our recipes. And now, just for safety, since we only want to ever have a single one of these objects, a recipe list SO, for this one we can go back here in the script and simply comment out the create asset menu. So now back in the game, over here we can no longer create another type of recipe list SO. So just a nice safety thing since we probably only need just one. And let's also add an underscore just so it shows up at the top of the list. Okay, great. So we have this, and now over here on the recipe manager, we can basically expose that in a serialized field. So let's make a serialized field. Make it private of type recipe SO list, recipe list SO, for the recipe list SO. And now here in the editor, we just drag that reference. All right, that's it. So basically the difference that we did with this method is over here on delivery manager, instead of having a list of all of our recipes, we just have a reference to one object, and then that object holds a list of all the recipes. In this specific use case, like I said, this approach doesn't really have many benefits compared to just storing the list here. But let's say we had another script that also needed a list of all of our recipes. If we did that, we would basically have duplicate references. So this script would have a list of all the recipes, then some other script would also have a list of all the recipes. And then if you wanted to add a brand new recipe, you would need to add it to all the lists on all the scripts. Whereas like this, any script that needs to know about all of the recipes just needs a reference to the recipe list SO, and whenever we want to add or remove a recipe, we just need to update this one object and everything works perfectly. That's one of the benefits of this approach, where you have a scriptable object to hold a list of all of the objects of some type. Personally, I find this pattern to be quite useful. Okay, so on Delivery Manager, we have a list of all of our recipes. Now let's just make a simple timer to spawn them. Like I mentioned previously in the spawn plate logic, you could just use a coroutine if you like that. Coroutines can be useful for running timers, but personally, like I mentioned, I do not like coroutines. I don't like the pattern they force you to use. So over here, I'm just going to make a simple float timer. So a private float for the spawn recipe timer, another one for the recipe timer max, and let's say 4 seconds. Then we just do a simple private void update. On update, let's count down the timer, so time.delta time. And if the spawn timer is under 0f, let's reset the timer. And now let's basically spawn a recipe. So for that, let's grab a random one from the list. So we go into the recipe list SO and grab the recipe SO list. Then we're going to grab a random one, so let's get a random index, so random.range between 0 and the recipe list SO dot recipe SO list dot count. So you get a random one. This is going to be a recipe SO for the waiting recipe SO. And then we simply go into the waiting recipe SO list and we add a brand new recipe. Okay, that's it. Super simple. Let's just make sure to initialize the list. So let's do here a simple awake for the waiting recipe SO list and just initialize it. Okay, so like this, it should be working. However, we're also going to generate recipes nonstop. We don't want that, so let's define some kind of maximum. So let's define a simple int for the waiting recipes max. Let's say we can have a maximum of 4 recipes waiting. And then down here when timer elapses, so if the waiting recipe SO list.count, if it is under the maximum, then we generate and add it. Okay, that's it, pretty simple. Now for testing, let's just add a log here to print the name. So debug.log on the waiting recipe SO that we generate. So let's print out the recipe name. Okay, so let's test. So here we are, and yep, one was spawned right away. So we have a salad, and after 4 seconds, yep, there you go, another salad. And if we wait for 4 seconds, we should have another one. There you go, a mega burger recipe. And finally, after 4 seconds, we have another burger. And now, no matter how much time passes, there should be no more since we're at the limit. And yep, time passed and no more. Okay, all right, awesome. So we are correctly generating recipes that the customers are waiting for. Now let's add logic to try to fulfill these orders. So over here on Delivery Manager, let's make a function to deliver a recipe. So let's make a public void, make it public since we're going to access this from the delivery counter. Call it deliver recipe. And the recipes are going to be delivered whilst on a plate. So let's receive a parameter of type plate kitchen object. And over here, the logic is actually going to be pretty simple. We just need to cycle through all of the recipes that the customers are waiting for and see if the ingredients on this plate matches the ones on any waiting recipe. So over here, let's cycle through all of our recipes. So let's do a for int I at 0, going through the entire recipe list.count, I++, okay. Let's grab the recipe SO for the waiting recipe SO. And we grab from the waiting recipe SO list on this index, okay, so we have that. Then first, let's do a quick test just to check if the waiting recipe has the same number of ingredients as there are on the plate. If not, then we already know that it's not valid. So over here, let's do a quick test. So waiting recipe SO, let's check the kitchen object SO list.count. If this one matches the plate kitchen object, let's get the kitchen object SO list and also check the count. So over here, we know that has the same number of ingredients. So this is the first check. Then we need to cycle through all of the ingredients on this recipe and all of the ingredients on the plate and basically see if both of them match. So let's first cycle through the ingredients on the recipe. So for each kitchen object SO, let's call it the recipe kitchen object SO in the waiting recipe. So let's go into the waiting recipe and get the kitchen object list. Okay, so here we are cycling through all ingredients in the recipe. Then we need to cycle through all of the ingredients on the plate. So let's do another cycle for the plate kitchen object SO. And we're going to go inside the plate kitchen object, get the kitchen object SO list like this. So here we are cycling through all the ingredients on the plate. Okay, so now here basically we need to see if this ingredient that we're cycling through if this one matches the ingredient on the recipe. So here we check if the plate kitchen object SO, if this one matches the recipe kitchen object SO. If so, then the ingredient does match. So in order to keep track if it does match, over here before we cycle through all the ones on the plate, let's define a bool for found or ingredient found. Let's default it to false. And over here, if we have matched, then this one becomes true. And by the way, over here, we can also break out of the cycle. Now, if you're not familiar with break, basically this is going to break out of the for each. So let's say the plate has 10 ingredients and the second one matches. When this cycle gets to the second one, it triggers a break, so it no longer goes through the remaining 8. So basically it breaks out of the cycle, so it keeps writing some code right down here. Okay, so we cycle through all of the ones on the recipe. Then we cycle through the plate, and if we do find that ingredient on that plate, then we have an ingredient found. So over here, if we have a not ingredient found, then over here that means this recipe ingredient was not found on the plate. So if that happens, then essentially over here we have a fail state. So the ingredient that this recipe requires is not on the plate. So let's go up here when we have the same number of ingredients. Let's define a boolean called the plate contents matches recipe. Let's default it to true. And over here, if we don't find at least one of them, then the plate contents do not match the recipe. And afterwards, we can check this bool again. So if this one is true, that means they all match. If just one of them does not match, then this one won't be false. So over here we know player delivered the correct recipe. So over here let's do a quick debug.log and print out a message. And after we do, let's also do a return so we stop the rest of the execution. So basically if we find a waiting recipe that matches, we don't want to keep going. And also here, if we do find it, let's also remove it from the list. So let's go into waiting queue, remove at, and remove at this index. Okay, so we're going to remove this recipe. But if this doesn't happen, then it's going to keep cycling, and it's going to cycle through all the recipes. So basically, if it reaches the end of this for, then basically no match is found. So the player did not deliver a correct recipe. So let's do another debug.log in here. Okay, so this is all of our logic. It looks a bit complex, but I hope this was easy to follow. When we see it in action, it all becomes a bit more clear. So all that's left is just calling this function from the delivery counter, so let's do that. Over here on the delivery counter, it accepts plates, it destroys plates, but before we destroy, let's go into the delivery manager, which means we need to access a reference. So again, we could add a serialized field, or in this case, it makes perfect sense to make this a singleton. So let's make it here, public static of type delivery manager, call it instance with a public get and a private set. Okay, then over here on awake, let's set instance equals this. All right, so now over here on the delivery counter, we can go into the delivery manager, access the instance, and deliver our recipe and pass in the plate kitchen object. Okay, that should do it. Let's test. All right, so let's look in the log to see what they are waiting for. So there are 2 cheeseburgers waiting, another mega burger, and a cheeseburger. So let's make a cheeseburger to deliver. So first of all, let's cook some meat. Let's slice some cheese. Let's pick up the meat before it burns, pick up the cheese, and we just need the bread. Okay, this is a valid cheeseburger, so let's deliver it. And there you go, the player delivered the correct recipe. Okay, great. Now let's deliver something that nobody asked for. Let's say just some meat. Actually, let's burn it just for fun. Alright, so there we have a bunch of charred meat, so nobody really wants this. But if we deliver, yep, there you go, player did not deliver a correct recipe. Alright, awesome, so over here everything worked. We have a bunch of recipes being generated, and then we have the logic so that when the player delivers something, it checks if the player delivered something correct or incorrect. So everything is great. All that's missing is obviously some nice UI, so let's do that in the next lecture.